Hey kids! Today we're going to start talking about stoichiometry. And stoichiometry is the quantitative relationship between your products and your reactants. So in other words, if you know how much of your reactants you put in, you should be able to tell me how much of your products come out. Or, on the other side, if you know how much of your product you want, you should be able to tell me how much of your reactant you need to put in to get that. For example, here is a flask of copper chloride and aluminum that we poured in. If I know how much aluminum and copper chloride I put in, I should be able to tell you how much copper and aluminum chloride I should get out of the solution. Let's do some real-world examples. Once a week, my roommate and I have game night, and this week is our week to host, and we're going to make Thai green chili. For every 2 servings of Thai green chili, we need 1 red pepper, and we need to make 8 servings. Let's use stoichiometry to figure out how many red peppers I'm going to need. So, in our example, we're trying to make some Thai curry. We need to make 8 servings, but first we need to look at our balanced equation. The first thing you'll do in any stoichiometry problem is write a balanced equation. So we know that we have 1 red pepper that's going to go in, plus some other ingredients that we haven't talked about, to yield 2 servings. We also know that we want to make 8 servings. So what we can look at is our ratio. Our ratio for red peppers to servings is 1 to 2. For every 1 red pepper I put in, I should get 2 servings out. So if we want 8 servings, we can set up our conversion factor. So 1 red pepper on top and 2 servings on bottom. Remember, we talked about our servings, and our servings have to cancel. So we have to cancel out our units still. So then when we multiply across, 8 times 1/2, we need 4 red peppers in order to have enough to make our Thai curry. We also need 3 tablespoons of green curry paste for every 2 servings. So can you figure out how many tablespoons of green curry paste I need? I need 12? Perfect. Thank you. So to make green curry, you also need those 3 tablespoons of green curry paste for every 2 servings that we're going to make. So we've taken our same equation and we've replaced our 1 pepper with the 3 tablespoons of green curry paste. And in order to figure out how much we want, we still take that 8 servings and then we set up our conversion factor. If I know that for every 3 tablespoons I put in, I'll get 2 servings out. 3 of the green curry paste for every 2 servings. We can multiply across, and 8 times 3/2 is 12. So we need 12 tablespoons of green curry paste. Alright, now that we looked at some real-world examples, let's look at some actual chemicals. If I've got potassium iodide and I mix it with lead nitrate, can you write the balanced equation? Pause the movie and see if you can figure that out. So you should have... Alright, so we wrote out our equation. Now all we need to do is balance it. We can look and we can say that there should be a 2 to 1 to 1 to 2 ratio. And remember, we talked about you don't really need to put the 1s in, but if it makes you more comfortable, feel free. So, this is what we call our mole to mole ratio. If we put in 2 moles of our potassium iodide, we should get out 1 mole of our lead iodide. Hypothetically, if everything goes perfect. So then the question is, if I want to make 2.3 moles of lead iodide, how much potassium iodide should I put in? See if you can figure that out. Any luck? So we had our 2.3 moles of lead iodide, and our ratio was 2 potassium iodide for every 1 lead iodide. So we set that up as our conversion factor. Notice our units still cancel. We have moles of lead iodide here, so our moles of lead iodide have to go on bottom. Then we just multiply across. You should end up with 4.6 moles of potassium iodide. Alright, so we can do moles. But what if I asked about grams? If I told you that you put in 17.8 grams of lead nitrate, and I wanted to know how many grams of potassium nitrate you'd get out, would you be able to tell me? Why don't you pause the movie and see if you can figure it out? How'd you do? If we put in our 17.8 grams of lead nitrate, we should get out 10.9 grams of potassium nitrate. How do we do it? We know our mole to mole our grams to mole conversion, because this is just molar mass from the last unit. So we take our grams and we divide them by our molar mass for lead nitrate, and then we use our mole ratio. So this is the stoichiometry piece that we're going to keep talking about for the next couple weeks. Can we relate one of our products and one of our reactants? So 2 moles of potassium nitrate for every 1 mole of lead nitrate, which comes from our balanced equation, are 2 moles of potassium nitrate for every 1 mole of lead nitrate. And then we take our molar mass of potassium nitrate, multiply by that, all of our units cancel, and we end up with 10.9 grams of potassium nitrate. So that's the basics of stoichiometry. If we know how much of our reactants we put in, we should be able to tell how much of our products is going to come out. So there is an assignment just below this for you to complete tonight on haiku. It's 4 multiple choice questions. It's labeled as an assessment, but it's not. It's your homework assignment. But you have 15 minutes in the assignment, so once you open it, it'll cut you off after 15 minutes and you get 1 attempt. So you know the password that you will need is curry, C-U-R-R-Y, so make sure to plug that in. It's not case sensitive, so you can just type it in. If you are a little lost and you're still a little confused, it's section 9.1 to 9.3 in your books. You can check there, or you can come in and see me.